Hi, I'm Bill and this is Math Fundamentals. Today we're going to continue the conversation that we've been having about quadratics. First we talked about area, then we talked about factoring. If you haven't seen the area video, you should check that out. Some of the ideas we use from there we're going to use in this video too. Today we are talking about multiplying polynomials. I guess first we should talk about what a polynomial is. Polynomials typically reference a number that's broken up into different terms. By that I mean you can have x squared plus x plus 3. Some ideas we haven't talked about if you've been following this straight through, which we'll cover in separate videos. As an x squared term, this has an x to the 1 term, and this one really has an x to the 0 term. If you're not familiar with that, it's okay, just think of it as the units have a separate term. So this is actually called a trinomial, because there's 3 types of terms. You can't combine these, you can't add them together. If we just had like x minus 3, you have the x term and then you have a unit term, so that's called a binomial. There's 2 terms. If you just had a single term, like you had 3, that's a monomial. If you had x, that would be a monomial. If you have x squared, that's a monomial. Polynomial just means many, so many terms. You can have something like 3x to the 5th minus 2x squared plus 8. That's technically a trinomial, but it falls into the polynomial category. So in multiplying polynomials, we're going to use the same idea that we do for area. So we had a rectangle with side lengths of 3 and 4. If you multiply 3 and 4 together, you'd get an area of 12. That's great, but we're going to work more with variables. So if you have a rectangle and you have side lengths of a and b, then in that case, your area is going to be a times b. Now let's make it a little tougher. If you have a rectangle and you have side lengths of a, and the other side is b plus 1. b plus 1 is still a number, because it depends on what b is, you're just going to add 1 to it. b could be 7, and then that side length will be 8. But when you're doing the multiplication in this case, it can be kind of confusing. So what I do is I break up my rectangle. In this case, since I have a b and a plus 1, I would split it in half here. So you have b on this part and 1 on this part, and then a is just the side length. There's nothing else to it. We don't split that up at all. And then when you're actually doing the multiplication, find where they intersect. So here you have a times b, which would be ab, and then here you have a times positive 1, which would just be 1 times a is a. We found the area separately. This is ab, this is a. We add them together to find the total area of the rectangle, and we get ab plus a is our area. Now let's take it one step further. Say we have a plus 5 is one side length, and a minus 3 is the other side length. We're going to break it in half here for the a and the plus 5, and then we're going to break it in half here for the a and the minus and the negative 3. So you have a here, 5 here, a here, negative 3 here. And again, we find where they intersect. So here you have a times a squared. Here you have 5 times a, or 5a. Here you have a times negative 3, or negative 3a. And here you have negative 15. Now we can add those all together. You have a squared plus 5a minus 3a minus 15. We can combine like terms. So here you have an a and here you have an a. You can combine those to be positive 2. 5a minus 3a would be 2a. So a squared plus 2a minus 15 would be your answer for the area. A shortcut when you're using this method is instead of writing all of them out and combining like terms, I usually just circle it here. It's usually on a diagonal. So then when I'm writing it, I would just write a squared, and then I would combine the 5a and negative 3a to get positive 2a, and then minus 15. It's just a little quicker, saves like a step, but it's not essential. You can write it all out. Now it doesn't matter how many terms are on one side. You can have 3x cubed minus 2x squared plus 5x minus 3, and then over here you can have x plus 1. And you're going to do the same idea. You're going to combine them wherever they intersect. So I'm just going to do this one really quick. This is just an alternative to doing all the distribution. I like it because I feel like it's a little more organized. It's harder to make mistakes if you line everything up like this. But when it comes down to it, instead of think of it as multiplying polynomials, we're thinking of it as area. I feel like it makes it a lot easier. I hope that helped to give you a way to multiply polynomials. I know there's some concept in here, if you've been following my videos from the start, we haven't talked about yet. I'm kind of shooting through this so I can cover quadratics, and then we're going to go back and cover things that you might have questions about. If you do have questions about some of this, leave them in the comments below. This way I can know what you want to see more of, what you need explained further. If you liked the video, please like and subscribe. Come on over to the Facebook group. There's a link in the description below. There we can have additional conversations. And thanks for watching. I'll see you next time.